This is AP Calculus 2-3. We are going to estimate derivatives of a function at a point. So what they're going to give us here is they're going to give us a function, and they're going to ask us to find the slope of the tangent line at a specific point on that function. Remember, in the last lesson we learned that if you take the derivative of a function, then that derivative can represent several different things: rate of change, velocity, the slope of the tangent line at a specific point. So that's what they're going to ask us to do here. So we're finding the slope of a tangent line, which is one of the main things you're going to do with derivatives. That's one of the main applications of derivatives. So it says find the slope of the tangent line of f of x equals 2x squared plus 1 at x equals 2. Now, in order to find the slope of the tangent line, we have to find the derivative. And remember, to find the derivative, we use the formula, the limit as h approaches 0 of f of x plus h minus f of x all over h. And if we then plug this formula in to the f of x function and then find that limit, we will have the derivative of the function. So let's go ahead and do that. This is 2x squared plus 1. So in for every x there, I'm going to plug in x plus h. So I've got the limit as h approaches 0 of 2 times x plus h squared plus 1. And then I'm going to subtract from that the f of x function, 2x squared plus 1. And I'm going to divide that by h. So if I solve that, we've got the limit as h approaches 0. If I FOIL here, I've got x squared plus 2hx plus h squared plus 1 minus 2x squared minus 1. That's still all over h. I'm going to distribute my 2. So that's 2x squared plus 4hx plus 2h squared plus 1 minus 2x squared minus 1. Then I'm going to simplify. The 2x squared cancels with the negative 2x squared, and the 1 and the negative 1 cancel out. So that leaves us with, if we bring an h out of all the other terms, h times 4x plus 2h. That's still over h. My h's cancel, leaving me with the limit as h approaches 0 of 4x plus 2h. Well, as h approaches 0, that 2h will become 0. It cancels out. So that means my derivative is 4x. So they ask us to find the slope of the tangent line, which means we have to find the derivative of the f function. The notation for the derivative of that f function is f prime of x, and we just found that to be 4x. Okay? I could say f prime of x equals all of that. That's what that means. That's the notation. So the derivative of 2x squared plus 1 is 4x. So this is f prime of x, the derivative of the f function. And then they want us to find the slope of the tangent line at x equals 2. Well, all we have to do here, once we find the derivative, is we're going to find f prime of 2. So we're going to plug 2 into that new function. That gives us 8. So what that means is this is not an ordered pair. That's not what that means. That means at x equals 2, the slope of the tangent line at that point is 8. Okay? So if our function, let's say, okay, that's a parabola. So let's just say our function looks like this. Let's say x equals 2 is right here. What that's telling us is the slope of that tangent line at that x equals 2 value is a positive 8. That's what that means. Here I have another example. It's similar to some that we've done already. It says f of x is a differentiable function on the closed interval from 0 to 10 for x. And it says find the slope of the tangent line when x equals 5. And then they give us a table of values for that function. They don't actually give us the function this time. So the only way we can use the limit process to find the derivative is if we have the actual function. But in a process like this, or in a problem like this, we don't have that f of x function to plug into the limit process. So what we're going to have to do is resort back to some things that we already know. We know that the slope of the tangent line is the derivative at that point, okay? Well, we learned in the first section of this chapter that if we have a table like this and they ask us to find the average rate of change, we said that rate of change is a slope. Well, we also know that derivative is a slope, okay? So, and we also know that the slope of the tangent line is a derivative. So the slope of the tangent line is basically the rate of change at the x equals 5 point. Okay, so what we're going to do here is 5 is not on there. So we can't find, you know, where 5 is exactly, but that's okay. We know x equals 5 is between 4 and 6. So what I'm going to do is I'm going to use the ordered pairs 4, 5 and 6, 3. Since we know the derivative is the slope of the tangent line, and I can find the slope using those 2 points, that's what I'm going to do here. I'm just going to find that slope. So 3 minus 5 over 6 minus 4 is negative 2 over 2, which is negative 1. So the slope of the tangent line on that closed interval at x equals 5 is negative 1. That's the best estimate that we can do without knowing the exact function that we have. Here's another example where you're going to have to use the limit process to find the derivative. It says to find the slope of the tangent line for f of x equals x squared minus 3x plus 2 at x equals negative 1. So go ahead and pause the video, see if you can get this one on your own. You're going to use the limit process to find the derivative. Then once you find that f prime of x, that derivative, you're going to plug negative 1 into that derivative to get the slope of the tangent line. So go ahead and pause the video and see if you can get that done. So here I have the answer for this. The answer here, the derivative of the f of x function, f prime of x, is 2x minus 3. And so when I plug negative 1 in to that, I end up with negative 5. Okay? So what that means is the slope of my tangent line when x equals negative 1 is negative 5. Okay? So we found the slope of the tangent line at x equals negative 1. So you can pause the video and look through this if you need to make sure, you know, if you made any mistakes, you can maybe see where you made those mistakes. Hopefully you got it right though. Then I wanted to make sure I pointed out to you that another thing they could ask me to do here is they could say, instead of just finding the slope of the tangent line, they could say find the equation of the tangent line. They could ask you to go to a step further, okay? So in order to do that, if you are trying to find an equation for a tangent line, you need 2 things, at least 2 things. You either need 2 points or you need the slope and 1 point on that line. So we found the slope when x equals negative 1. Our slope is negative 5. But we would also need to find the ordered pair at x equals negative 1 if they ask us to find the equation of the tangent line, okay? Now, in this problem originally, they just asked us to find the slope. But now I'm going to turn that around and I'm going to say, now I want you to find the equation of the tangent line. Now, you need to know the difference between the two. If they ask for the slope, we're done. That's all we have to do. But if they ask us for the equation of the tangent line, we have to go a step further. Okay, we would do all of this work and get the slope. Then we have to find the ordered pair when x is negative 1 on the original function. Well, if you look at that original function, x squared minus 3x plus 2, if I plug negative 1 into that, won't that give me the ordered pair for that function at x equals negative 1? Okay, so if I do that, if I find f of negative 1, well, negative 1 squared is 1. Negative 3 times negative 1 is positive 3. So 1 plus 3 is 4, plus 2 is 6. So the ordered pair, when x is negative 1, is negative 1, 6. And so then, if I want to find the equation of the tangent line, all I have to do is put that in point-slope form. Now, hopefully you remember from algebra, point-slope form is y minus y1 equals m times x minus x1. My x1 and y1 is the ordered pair. My slope is negative 5. So this equation would be y minus 6 equals negative 5 times x plus 1. That is the equation of the tangent line. So the slope of the tangent line is 5, or I'm sorry, so the slope of the tangent line is -5, but the equation of the tangent line is y minus 6 equals -5 times x plus 1. And that is all when x equals -1. Now, they could give me any point here. They could say find it at x equals 5 or at x equals 1. It doesn't matter what x value they give us. The process is going to be the same. The only difference would be once we find the derivative, then we would plug whatever the x value is to get the slope. And then we would plug that x value into the original function to get the ordered pair, and then we'll have enough information to find the equation of the tangent line.